form. For the altitude, they have divided the troposphere into 3 layers. The lower layer from 0 to 2,000 meters, the middle layer from 2,000 to 7,000 meters, and the upper layer from 7,000 to 11,000 meters. We can identify which layer a cloud belongs to by its prefix. Cirro for the upper layer, alto for the middle layer, and the absence of a prefix for the lower layer. The second criterion is the form. 2 main cloud forms are distinguishable: layered clouds, which are referred to using the word stratus or strato, and accumulated clouds, the word cumulus and cumulo being used for them. Within the upper layer, we see cirrus, cirrostratus, and cirrocumulus clouds, which are mainly composed of small ice crystals. Notice the 2 letters you see before the name of each cloud. They represent the international abbreviation for each particular cloud. Within the middle layer, we find clouds composed of water droplets called altostratus or altocumulus. Finally, we see stratocumulus and stratus clouds at the lowest altitudes. Since we glide at that altitude, these are the clouds we usually pay attention to. Stratus clouds are the lowest. They form fog or white blankets of mist at the bottom of the valleys in the morning. Stratocumulus may at times cover the entire sky. They are generally grey. Then you have cumulus clouds, which develop throughout the day due to thermal lift. This is why they are a paraglider pilot's favorite clouds. Finally, there are clouds with an impressive vertical development, such as cumulus congestus, nimbostratus or cumulonimbus. These clouds belong to several levels at the same time. Cumulocongestus are cumulus clouds that have kept on developing vertically. Their bulging shape is typical. At this point, they become very dangerous clouds for our activity. A nimbostratus cloud is very dark at its base and quite thick. It's a rain cloud. Because of its strong vertical development, and more so because of its lack of visibility, it is a dangerous cloud for free flight. Then there are cumulonimbus clouds, which can develop and extend as high as 12,000 meters. This cloud is by far the most powerful. You're better off admiring this type of cloud from the ground. For mountain flying, when flying early in the morning, you need to wait patiently for the sun to warm the hills, because this is what creates the first breezes of the day. Let's look at how breezes originate and how they evolve throughout the day. Breezes are a localized phenomena that depend on a specific location's topography, vegetation, and most importantly, its exposure to the sun. Throughout the day, the sun will warm the hillside, causing the ground temperature to increase more rapidly than the water temperature. These conditions are what causes a breeze. The ground will warm the air above it through conduction, making it less dense or lighter and causing to rise. The result is a lift. And since nature hates vacuums, the space left free by the ascending air must be filled. The land in this case becomes a vacuum, sucking in air from the sea. A sea breeze fills in the void created by the convection. At night, the exact opposite takes place. The land cools much faster than the sea, creating the necessary conditions for a new breeze. This time, the air over the sea is warmer, hence it rises, generating a vacuum that sucks the air from land out to sea. This is called the land breeze. It usually isn't as strong as the sea breeze. Let's observe how the same phenomena occurs during various landforms, starting out with the morning. The radiant heat from the sun warms the eastern-facing hillsides. The hillsides then conduct that heat to the air above it. This air, having been rendered less dense, rises up the length of the hillside. These are called uphill breezes. Learning how to paraglide under these conditions is ideal. The gentle, uphill breezes will help inflate your wing, and you will experience little turbulence in these slightly elevating air masses. Throughout the morning, this phenomenon increases in intensity until around midday. This is when the sun is almost vertically overhead, which causes the greatest uphill breezes on the southern-facing hillsides. These breezes, called valley breezes, move in to fill the void left by the rising warm air. Late in the afternoon, the eastern-facing hillsides begin to cool off and the air becomes heavier. This air falls down the hillside, creating downhill breezes. These breezes help fill the void in the valley, as well as the one created along the sun-exposed westward hillsides. At sunset, air temperatures at higher altitudes are cooler than those in the valley or along the plain. Downhill breezes move in to rebalance the system. Certain phenomena, such as turbulence, can make a flight uncomfortable and dangerous. You should be comforted by the fact that during your training you'll be flying under calm conditions and on familiar sights, all the time accompanied by experienced instructors. Nevertheless, recognizing and understanding these hazards is the first step towards knowing how to avoid them. Let's begin by looking at turbulence. Turbulence comes from the chaotic movement of air within an air mass. They can be divided in two main types: obstacle turbulence and shear turbulence. Let's first look at obstacle turbulence. When the wind blows over an obstacle unevenly and discontinuously, turbulence forms. Air constantly flows up to the top of the windward side of this landform, but as soon as the air passes over to the leeward side, a depression forms, generating turbulences called rollers and rotors. There may also be areas of the windward side where turbulence occurs. For instance, if the windward side is hilly or irregular, turbulence will form in the immediate vicinity of the obstacle. Of course, in some cases the obstacle generates no turbulence at all, neither on the windward side nor leeward side, such is the case here, where this particular landform creates a dynamic lift. Similarly, the airflow on the leeward side of obstacles such as a hedge of trees or a house can also be turbulent. For this reason, landing downwind of such obstacles is not recommended. Let's now turn to the other type of turbulence, shear turbulence. Shear turbulence occurs where two air masses move against one another. This is the case around a thermal lift, since warm air rises in the center and cooler air descends around it. When you fly into a thermal, you will feel the effect of this shear turbulence on your wing. Another example of shear turbulence you're likely to encounter when flying is the case of two superimposed air layers that are moving in opposite directions. Shear turbulence is present along the border separating the two layers.